Okay, guys, I saw this problem posted on a video by BrainStation, which is another YouTube channel, a very famous one from what I see. They have more than 300,000 subs. The claim is that only 1% of people can solve this problem and that this is a Harvard entrance exam problem. And as a Yale person, former Yale person, I felt like, come on, this should be a piece of cake. Okay, I'm joking, it wasn't a piece of cake, but I took a little bit of an alternative approach to the problem that I found interesting. So I want to show my approach to the problem, and I'm going to provide a link to the original video in the description. And shout out to BrainStation for the nice problem. I really enjoyed it. So let's write down the solution. Okay. So we are not allowed to square both sides to get rid of the square root. Okay, so that much is clear. So let's start by copying down the equation again. Okay, so this is our equation. Let's bring x squared to the left hand side, and let's take the square root to the right hand side. Okay, so this was the first thing I did. Okay, and since this is x squared, then x is simply plus or minus the square root of 5 minus the square root 5 minus x, which is a rather scary thing to see. Okay, so there are two roots per se to say. So x can be positive, the positive of that expression, or the negative of that expression. So let's take the positive root. Let's go to a clean page. So for the positive root, we have that x is the square root of 5 minus the square root of 5 minus x. Okay, then notice that I have the x appearing over there, right? And x is equal to that, right? Which is kind of crazy. So let's plug in x to see what will happen. So we'll get a scarier square root that will look like this: 5 minus the square root of 5 minus 5, sorry, minus the square root of 5 minus the square root of 5 minus x, right? So this is what happens if I substitute x once, but nothing prevents me from doing it again, right? So I can plug in x again inside this square root. Okay, so I will have 5 minus square root of 5 minus the square root of 5 minus the square root of 5 minus the square root of 5. And I can keep doing that forever pretty much, right? Minus the square root of 5. I ran out of screen. Actually, let me erase a few of these. And I hope you get the idea. But you pretty much get an infinite nested radical, as it's called. So let's just do x there, okay? So I can keep substituting x into this square root and get a more and more nested, further nested, I don't know how else to say it, square root, okay? But then notice that this part is nothing more than x, right? So we go back and forth with this. If this doesn't make sense, ask me in the comments and I will explain. But since we keep substituting x into this expression, then we can just realize that this is nothing more than x, this part over here, okay, that I wrote in red, okay? So let's see what will happen. So we'll get that x is the square root of 5 minus x, okay? This is much simpler to deal with, okay, because you can take the square root of both sides now. Okay, notice that they prevent us from taking the square of both sides in this expression, okay, which is different from this expression. So I just took the square of both sides, and now I have a regular, a rather simple quadratic, right, equation. So x squared is 5 minus x, so we get x squared minus x plus x minus 5 equal to 0. That has two solutions, x1 and 2 equal to minus 1 plus or minus the square root of 21, because it's 1 squared minus 4 times minus 5, which is 20 plus 1, 21 over 2. Okay, so we get two roots from here, x1 equal to minus 1 plus the square root of 21 over 2. And if you go through the trouble of plugging this root, plugging x1 back into the original equation, you will see that both sides are satisfied. Also, you can notice that the right-hand side, 5 minus x squared, must be a positive number, because on the left-hand side, we have a square root. So I'm assuming that they are looking for real solutions here, okay? So to get real solutions, you need the right-hand side to be positive. And this only happens with x1, okay? So that's a solution, whereas x2, which is minus 1, minus the square root of 21 over 2, is not a solution because it gives us a negative right-hand side, and that doesn't work, okay? Right, don't forget though, okay, we're not done, because we started with this expression, and we took the positive root, okay? We also have a negative root. So let's go see what's going on with the negative root. So negative root, okay, I tried to make it work with infinite radicals, and I didn't get anywhere, so I thought of a different approach. Let me show you. So for the negative root, we have x equal to the negative of 5 minus this nested square root, okay? You can do the same thing as we did before and get nested square roots. I tried it, I didn't get anywhere, but that doesn't mean that will never work. I mean, if you find a way to make it work, let me know in the comments. But what I did was instead to set this equal to y, okay? So y is the square root of 5 minus x, okay? And then since we did that, then x is automatically equal to the square root of 5, the negative of the square root of 5 minus y, okay? I hope this makes sense. So if we take the square now, we have y squared equal to 5 minus x, and x squared is 5 minus y, okay? And then we have these two equations. We can subtract them, right? We can subtract y squared from x squared on the left-hand side. So this is an x squared. So in the right-hand side, we will have 5 minus x, that comes from the y squared term, minus x squared, which is 5 plus y, because minus of a minus gives us a plus. So the 5's go away. That's a nice cancellation. And then we can expand this into y minus x times y plus x, okay? And on the right-hand side, we have y minus x, okay? And we can delete this, provided that y is not equal to x, okay? Because otherwise we'll get a division by 0, which is not allowed, okay? So we will have y plus x equal to 1, right? So y is minus x plus 1. And we can plug this into, let me see, what did I do? We can plug this y into this equation, okay? Into the x squared equation. So if we do that, we get, let me see, x squared is 5 plus x minus 1, which gives us a nice equation again, x squared minus x minus 4 equal to 0, which has two solutions, x1, 2 equal to 1, plus or minus the square root of minus 1 squared, which is plus 1, minus 4 times minus 4 gives us 16, so plus 1, 17 over 2. Actually, I should name this as x3 and x4 because x1 and x2 were the previous solutions. So x3 is 1 plus the square root of 17 over 2, which doesn't work because the right hand side of the original equation becomes negative. Okay. And then x4 is 1 minus the square root of 17 over 2, which works. Okay, so we get two roots. This one, x4, and this one, x1, which agree with the video by the video that I mentioned in the beginning by BrainStation. So I just wanted to provide an alternative solution. I really like challenges like this. I'm a physicist, but okay, to be a good physicist, you need to be a good mathematician as well, I believe. And I'm not claiming to be a good physicist or a good mathematician. I just like these things. So I hope you enjoyed this video. Again, thanks to BrainStation for uploading this. I'm not good with coming up with my own problems, so it's better for me if I see a problem and I solve it. So I hope you enjoy it. Let me know what you think in the comments, like, subscribe, share, something like that. See you in the next video.